Question 9. The diagram shows a tennis ball thrown vertically into the air. Okay, so we have a person, the ball, throwing it upwards into the air, going from position C to B to A, and then obviously back down from A, then B, then C. Question A. At position C, the ball has just left the player's hand at a speed of 5 meters per second. The tennis ball has a mass of 0.058 kilograms. Calculate the kinetic energy of the tennis ball at position C. As always, we have to start from the equation, which in the case of kinetic energy is Ke equals 1/2 mv squared. The value for mass has been given as 0.058, and the value for the velocity has also been given as 5. With that in mind, we can simply plug in the values, giving us 1/2 times 0.058 times 5 squared. That will give us an answer of 0.725 joules. Question B. At position B, the tennis ball has 0.38 joules of gravitational potential energy. Calculate the height of the tennis ball above the player's hand when at position B. So this time round, instead of giving us the values and we have to find the energy, he's given us the energy and we have to find the value for the height. So straight away we have to start from the equation. GPE equals mgh. Gravitational potential energy equals mass times gravity times height. And we have to get h subject of the formula, which means we have to take mass and gravity over to the other side, turning them into a division. So that will become h equals GPE divided by mg, which means gravitational potential energy divided by mass multiplied by gravity. Plugging in the values, that will give us 0.38 divided by 0.058, the mass of the ball, which we got from the original question, multiplied by 10, which is gravity. We always take gravity to be 10. The answer there will be 0.655 meters. Question C. What does the principle of conservation of energy state? This is one of those questions that we have to know by heart. And the answer there is energy cannot be created or destroyed, it can only be transferred from one form to another. Moving on to question D. A climber uses 13,500 joules of kinetic energy to climb a mountain. Calculate the potential energy he will have once he reaches the top. Now, according to the principle of conservation of energy, since energy can only be transferred from one form into another, then if he has used 13,500 joules of kinetic energy, then at the top he should have 13,500 joules. But to make the answer a little bit more concrete and substantial, we can write this. Kinetic energy at the bottom equals gravitational potential energy at the top. Therefore, the answer is 13,500 joules. Question E. The climber has a weight of 660 newtons. Climbs should be removed there. And the cliff that he climbs is 20 meters high. Calculate the work the climber must do against gravity to climb to the top of the cliff. So we know that work is equal to the force multiplied by the distance moved in the direction of the force. So the force has been given to us as 660 and the distance as 20 meters. So we simply have to plug in the values and work it out. From work done equals force multiplied by distance, we can get 660 times 20, which will give us 13,200 joules. Finally, question F. It takes the climber 800 seconds to climb to the top of the cliff. During this time, the energy transferred to the climber equals the work done by the climber. Calculate the power of the climber during the climb. For power, we know and we have an equation, which is power equals the energy transferred divided by time. But we've been told in the question that the energy transfer to the climber is equal to the work done. And we've already found that in the previous question. We've also been told that it took him 800 seconds. So once again, we can simply plug in the values. So the power here will be 13,200 divided by 800. That will give us an answer of 16.5 watts. And that concludes question 9.